Cool. Hey, everybody. Thanks for coming to Module 4. This week we're covering Forge, the Ethereum development toolkit. But before we start, does anyone want to share their homework from last week, and we can go through that withdrawal function and see how we implemented it? I know, Victor, you said you did it. Do you want to share your screen, maybe?
Just give me a sec.
No worries.
Oh yeah, and just remember to close like WhatsApp all communication thingies so messages don't pop up.
Just need to find the.
Did I put you on the spot there? But sorry.
Slightly.
I can share mine if you don't want to share yours. That's cool.
I
think
of
he just needs to find it in all the files.
yeah. I did kind of cheat. So you might have to.
That's fine.
Oh, okay. Wait. I've got something. Okay. Gonna have to join the call. It's because it's on the other computer. Okay, can you guys hear me?
Can hear you, yeah.
Okay, cool. Let's see. All these pop-ups, honestly. Okay.
Nice.
Deposit withdrawal.
Cool.
And there's a little transfer. But there's a withdrawal.
Good. That's cool.
Check balance.
Yeah, that's great.
Available.
Increase balance. Great. You used call. That's great. And then you check the require. Oh, it's perfect, dude. That is perfect.
I did go a step further, but we can keep it for afterwards.
Okay. So you got a transfer function as well to transfer ETH from one to the other person in the contract. So just updating balances of one person. That's nice.
Yeah. But there's also a front end for it.
Yeah. Oh, really? Oh, that's awesome. Wait. Let me go back there. 2 starting to address 0. That's perfect. Cool. There's just this one thing that we're kind of missing in those two functions. It's a very minor thing. It's just that we check as well that the amount someone's trying to withdraw is not 0, so they don't spam your contract.
0 check.
Yeah, that's it. Otherwise, it's perfect, dude. Nice.
Yeah, that checks for balance. Yeah, balance.
Because 0 will always be less than the balance of the person. So the call will succeed. But it would just spam your contract or your front end with unnecessary transactions. But otherwise, really, really well done, dude. This is nice. They show me, okay, I can try front end. Yes, dude.
So I'm just curious about. So obviously, spamming the front end would cause problems with like what you're running. But spamming the contract, like, what's the risk of getting your contract spammed?
You would just you would run into block issues where the transactions would fill up and then other users wouldn't be able to get space in the block, and then they'd have to wait. So you would slow down the use for other users. If you, that's about it. It's just like a awful
But would it cost you
slowing.
anything? So you're just
No,
breaking the network, but it won't cost you anything to break the
no,
network.
well, yeah, it won't cost
Okay.
you anything. It's just like you would degrade user experience terribly.
So is it a DOS? Like, so technically,
Kind of
is
a
it?
DOS, yeah.
Okay. So why is it still legal then, from a security standpoint? Just curious.
Well, you can do it. It's just you gotta check for it in your contract. That's like standard operating procedure.
Okay, no,
Uh,
no, because
with-
I'm just thinking of like, if it's a variable that could be executed incorrectly, and if you have enough users incorrectly executing it, you could just DOS the whole network or DDoS.
Yeah. So if you have like someone trying to withdraw a ton, like a whole lot, their transactions are just it's gonna clog up your whatever you're using. If you're using an indexer to sync with your front end, it's gonna cause a whole lot of issues.
Okay, cool.
Yeah, it's gonna make unnecessary transactions.
Yeah, but but it's not going to affect you as much as the network. So has it ever been used as an attack vector to actually just denial of service attack on a network, or distributed denial of service attack that you can think of?
Not that I can think of in the recent past. But I think it's just because standard operating procedure has like kind of snuffed it out.
Okay, fair enough.
I think it might push up gas prices because it has to process so many more transactions.
Yeah, that's true. I didn't actually think of that.
Yeah, but wouldn't that be like a bad actor in terms of
Yeah, you'd make it more
a
expensive.
validator? Like if you were a validator and you owned enough validators, you could actually just be a bad actor to increase your earnings.
Yeah, but then you'd get slashed by the other validators. It would be like this guy.
Yeah, but only if they figure out it's you that's releasing the bad contracts. It's like, okay, never mind.
Yeah, okay, sorry. So show us you could have kept that, Jake. Oh, you just copied it. Okay, cool. Yeah, perfect.
Okay. Okay, I'm not much of a front end person.
Okay.
But I do know some people who are sharp with it. So it's a little ATM
Nice.
skin.
That's pretty sweet.
Connects to the local contract. I did deploy the contract to the local Anvil.
Oh, nice, dude.
That's my wallet balance.
Yeah.
Very, very, very lucky. Fortunately. And then I say deposited. There's wallet update and there's deposit.
Nice. What are you using to keep you up there? To read events from the chain?
I think it's just using Veeam.
Oh yeah. Oh, and you just listening to the.
No, it's Veeam and React.
Okay, cool. Nice, dude. Very nice. That's so cool.
Oh, and it lists the last transactions.
Nice. I'm well impressed, dude.
Also pulled in the.
Hey. What are you doing there? Showing private keys?
It's fine. It's my local stuff. And then receipts. I mean, this is nice for local dev, so you can load it into your MetaMask.
Yeah, it is. But it also shows it to you in your terminal when you're running Anvil.
Yeah, it does, but it's a schlep to go and find it and copy.
Yeah, okay, true. That's true. I can't argue with that.
So just having that all.
Nice.
I think that's all.
Oh, and a quick import button. Oh, that's awesome.
quick input might be there somewhere. Here's another.
Yep.
Oh, I have to switch over to this one. Connect. Oh, there's millions and millions. I'll say. So it's fresh deposit. Let's see it goes.
There it goes. Sweet.
I'll say. I think I might have deposited to this one before. That's why that.
Yeah, probably.
Anywho,
That's really cool, dude. Really, really cool.
I'll say. Can I deploy this for hackathon?
Probably not.
Okay, over to you.
Cool. Okay, I'm sharing my screen. Okay, we are at module 4. The smart contract lifecycle using Foundry. Okay, so what is Foundry? So like Foundry is a smart contract development toolkit for Solidity. It's written in Rust, not JavaScript, which means it's super fast. And it's an Ethereum-native workflow, which means there's no context switching, so you don't have to jump between JavaScript and Solidity. Everything is written in Solidity, from tests to scripts and everything in between. It's all Solidity, which is really, really cool for smart contract developers. It comes with 4 built-in tools: Forge, Cast, Anvil, and Chisel. Forge is basically it does everything that you do, like mainly for development, compiling, testing, deploying. Cast is your command line interface for interacting with contracts on chain. So you don't need a front end, or you don't need to build a front end in order to interact with contracts that you've deployed. You can just use Cast and interact with them directly from the command line. It comes with Anvil, which is a local Ethereum network that spins up directly on your machine. Anvil's super awesome because you can deploy contracts and then get Anvil to dump its state into a JSON file. And then you can give this to a front-end developer, and they can spin up this particular instance and have all the contract instances deployed and transactions happening on the Anvil network up to that point, and then they can just build from there. You can also fork networks using Anvil. So you can fork mainnet from a current block or any block that you wish, and it will have the state of mainnet at that block. And then you can test your contracts with the live contracts that are out there in the wild and see if they will interact properly. Also comes with Chisel, which is a REPL. And that's just for quick iteration. You can write a few lines of code and then interact with it and see what it does and if it works. So that's just for like quick playing around for iteration on ideas. So why Foundry? Well, it's super fast. It's way faster than Hardhat. Hardhat was the previous preferred development toolkit, but it was written in JavaScript. And it was but like pulling teeth to do anything. You would have to do like gymnastics to do a simple token transfer, or just like load up a token, or fork a network. It was very difficult. Whereas Foundry is just like a one line call that spins up a network or forks a network, or it's just a lot cleaner. It's better for testing and better for auditing when it comes time to send your contracts for audit. It's also closer to the EVM than what Hardhat is, because Foundry is built to mirror the EVM as closely as possible. So to install Foundry, you just run this one line, curl-l, and the URL for the Foundry GitHub. And then you just restart your terminal and it installs. So I've got mine installed already. To check your installation, you just run forge -- version or cast -- version, and it should give you the version that's installed. If I show you my screen, my VS Code, I can go forge -- version, and it will tell me I'm on version 1.5.1, which is the latest stable release. There's the commit hash, there's the build timestamp, and that's all the information about the latest version that I'm running. You can run Foundry up if you want to update to the latest version of Forge. It does do a nightly build where they update. You can download the latest version every night if you so wish. But I like to stick with this single stable version. Okay. Now we come to actually writing smart contracts in Foundry. So Foundry will give you this basic file structure that we have here when you install it for the first time. So you can see if I run forge init, and it's a demo contract. That's the name of my folder. I say init, it will just pull all the Foundry repository from GitHub, and then I can cd into this demo contracts folder that it created for me. And oops, I should actually open it from here. And here we can see the layout that Forge gives us. Gives us a source directory for our contracts, gives us a test directory for our tests, and gives us a script directory for our scripts. These are all written in Solidity, as you can see. Yes.
Sorry to disturb you. Did you install Forge via VS Code or straight from Windows?
From terminal. Yeah, you can just open your terminal, and then if you're on your desktop, you just copy this here curl. You just literally copy this. Oops.
So do you put this in the command prompt?
Yes, and you hit enter, and it will download.
It's then installed.
Yep. I don't know so much about Windows. Running it on Mac, but maybe some of the other guys can help you if you are running into problems using WS.
Because I'm using Windows 11 Pro, so I don't know how it works.
I don't know if I can chime in for a sec. So yeah, it's exactly the same. So essentially, I don't know, I can show you. But it's basically the same thing. You just click on terminal, new terminal, and then you paste in the code. But if you're not using VS Code, then you're going to have to use a different command and not curl. So what you have to do is go onto the Foundry site, a Forge site, sorry, and then figure out what you need to download, and then it'll give you two different commands.
Yep.
Yeah.
So I don't know if you want to just show that link, and then you'll see there's like a Windows one and a Linux one, and then a something else.
But if it's a Windows 11 Pro, how do you install?
It's just a command. So it's the same basic thing. So there you see it says is that for everything? Yeah, then try it, see what happens.
Get started.
Get foundry.sh.
Windows Foundry requires the WSL PowerShell command prompt are not supported.
Oh, so you have to use WSL.
Yeah.
But you installed WSL?
Yes, I did.
So what you can do then is click on your WSL version. Click okay. I have to pick, like, you just basically click type in code, and like in the folder you're in, you press dot, and then it'll take you to that folder. I don't know if you can show, like, Miles, your typing should be the same, or your thingy. So if you just go into a terminal,
Yes.
and then not into your terminal, Miles, like your command prompt. Yeah.
Yep.
So if you actually just like go to the directory that you want, so once you're in VS Code, you just say cd, and then you figure out what directory structure you want to go into, and then from there you just type in code dot, and then that'll open up a VS Code using thingy,
In
the
that
directory from
Yeah.
using the WSL directory structure and everything. So it's running through. So now if you click on terminal thingy, and then you'll see. So dot.
Yep.
And then it'll actually show you the same location in the terminal. So now you'll be inside the Ubuntu system. I just want to check if I'm not messing you around here quickly. Sorry, just give me 1 second. And if I go to file, where would I go? Terminal. Now it wants to do all of these things about trusting files. What am I trusting? Miles, what did you install? You're making me trust stuff. So you just say new terminal, and then your terminal structure, your file structure would be exactly that spot. So on mine, it says Microsoft PowerShell core file system //WSL. So I can see that I'm definitively in it. So now if I had to run that curl command, it would work perfectly. Sorry for not sharing screen, but
Okay.
cool.
Cool. So yeah, that's our basic file structure. As you can see here, this is a simple vault contract that we can. It's pretty much the simple bank that we wrote in the last one. And you can see we store it in the source folder with our other contracts. So in this case, it's the counter contract that has 2 functions. All right, here we go. So in order to compile a contract, when we have a contract that's written like this, we can just hit forge build, and it will compile our contracts for us. And there you see, compiler done successful. It compiled 23 contracts with version 0.8.28. And when you compile your contracts, it then creates these 2 folders, a cache and an out folder. In the out folder, it puts all the contract APIs that's for you. So you can find, if you want to give it to your front end guys, or you want to build the front end, there's your API for the counter.json. Right, prettier. You can see there's your API with all the function calls, the inputs, and everything. So you give this directly to the front end, and they would then use this to call this contract. Okay. So basically what happens when we compile, the compiler reads the Solidity source files that we gave it. It compiles them to bytecode. It outputs the artifacts to the out folder. And then it just makes the bytecode ready for deployment. The compiler has different settings that we would set in our foundry.toml file. That's basically the configuration file for not just compilation, but deployment and all sorts of other settings that you can add. This toml file, it normally contains your SalkC version, which is the compiler version that you're using, and various optimizer settings that you can see here. So if we put the optimizer enabled and we give it 200 runs, what the optimizer does is it will just, on compilation, it will just optimize your code for deployment and then make it cheaper for you to deploy to the chain. Depending on the amount of runs that you give it, the lower the amount of runs, the cheaper it is to deploy, but the more expensive it is to interact with. So your gas cost will be slightly higher. If the optimization runs are higher, you'd have more expensive contracts to deploy, but it would be cheaper to interact with. 200 runs is about the default, and that's a good balance between build size as well as gas costs for when functions are called. So here's an example of a TOML file. And you can see it's got the SalkC setting, it's got the optimizer and the runs. It's also got your RPC endpoints over here, which is just the endpoints that you would use to access the particular network. So you'd have a mainnet one, you'd have an Anvil one, you've had this one just got a Sepolia testnet one. And then it also holds the links to your API keys, whichever API keys you are using. This one is specifically for Etherscan, so that when I deploy, I can verify directly in one call for the Sepolia chain. So your TOML file is basically the configuration file for your entire project. Next, we come to testing. So when we write tests in Forge, it's all in Solidity. The testing goes in a test folder. And if you can see on this, slide here, we've got one test written, but we've got two functions. So basically at the top of the file, we import our simple vault or simple bank that we wrote, and we set up a few people to interact with it. We've got Alice, we've got Bob, and we've got the owner who's going to deploy the contract. Then we have a setup function. Now what the setup function does is it runs every time before each and every test, and it sets up a clean state for the contracts, for the tests to run against. So one test will never affect another test in your unit testing setup. The setup function will run before this test deposit function, and it will set up Alice as an address, it will set up Bob as an address, and it will set up owner as the address. Yeah, you can see there's two different ways to create a user. We've got the vm.addr. That's just using the built-in Foundry virtual machine to create an address, and you can just pass in a normal number, and that will create an address from that. You can also use the make addr function, and I think this one is a bit simpler to use, where you can just pass in a string and it will make an address out of that string. Next, we've got the deal function below that. This deal function is built in to the testing file or via virtual machine with Foundry. And this deal function simply just gives whoever you pass in some ether. So in this case, it's giving Alice 1 ether and it's giving Bob 1 ether to deposit into the simple vault. And finally, it uses the vm.prank call. And this is basically, it just says that the next line or the next call is going to be called by this address. So in this case, it says the deployment of the new simple vault is going to be called by the owner address. So in this case, the owner would be the message.sender, and they would then be set as the owner in that simple vault. You can also do start prank, which would then make all calls that follow that function call be called by that specific address until you write stop prank. So in that way, you don't have to write vm.prank after every call you want to make. You can just start it and then stop it. And then you have finally a one test here at the bottom. It's a test deposit. And basically, it just allows Alice to deposit 1 ether into the vault and then checks with assert equal. It asserts that the vault's balance for Alice is now 1 ether. So the balance updated correctly. We can see in our example over here, that if I do forward test, it compiles everything. It runs 2 tests that were in the counter.t.sol file. And you can see it's the very same setup function it tests the increment function, and it tests the set number function, right? This is a very simplified testing setup, as it doesn't use any actors. It doesn't need any actors to be portrayed. It's very, very simple. And in this case, the caller of this function is simply just this testing contract. So if you do not use vm.prank, the testing functions automatically assume that the caller is the contract, the test contract itself. So here we can see we've got two different types of tests. This is the magic that Forge gives us. It allows us to write fuzz tests as well as just normal unit tests. So this would be a unit test. It basically just tests that the counter does, the increment function does what you say it does. It just increments it by 1. But a fuzz test is usually a test that's written for a function that takes in an argument. So in this case, set number, or the function set number, takes in a number. And in a normal test, you would have to write something like, if I copied this, in a normal unit test, you would write something like test set number, counter.set number, then, right? And then assert that the number you set is 10. And every time you run this test, it's going to call this function with 10. But a fuzz test, this now Foundry now randomly inserts numbers for this variable. So it will, you can control this in the TOML file as well, but this will now go on the first run. It will say pass number 1, then pass number 5, then pass 10,000, then pass 100,000, then pass 6, and it will check that the counter is updated as it should be for all those numbers. So this is very useful for catching edge cases, especially testing max values and min values and very weird decimal values and that kind of thing. If you're working with mathematical functions, this fuzz testing can be super, super powerful. So testing can also be run on a per test basis. So as you saw there, I did Forge test. That runs all tests in a testing suite. There you go. We ran 3 because I wrote a new one over there. But if I were to just want to run the increment test, I could do Forge test -- match test and the test name test increment. Right. And go on, and it just ran that. It told me it passed, didn't fail. You could also run your tests with some verbosity, so it gives you some extra information about the test. If you do -v, it will give you some information that's basic. You could do -vv. If you have any logs, like if I said sol.log hello, right, and I have to import console. So, right, -vv would print out that log. So you can see log is hello world. Whereas if I just did -v, doesn't print any logs. You could do an extra one. This would run the traces for the test, and you could also do -vvv, which actually gives you all the information you could ever want about what this function is doing. It tells you here that the counter test contract is calling test increment, calls increment there on the counter contract, then it stops, then it calls the number and it checks what the number is, it returns 1, and then it logs hello world. So that's the power of using testing in Foundry. As you can see, the tests run pretty fast. And setting them up is really, really easy. So here we go. You can see when we execute all tests, we just run forge test. It spins up a local EVM directly on your machine. Then it runs the setup file before each test and executes each test function. It also reports gas usage per function, which can be very, very useful. It will show failures and successes, and it will most of the time tell you why a function has failed. So if I say assert counter number is equal to 9 and not 10, and I run this test, so forge test -- empty shorthand test set number -VUE. It will tell me that this test has failed, and it failed because 10 is not equal to 9. So I set the number to 10. I expected it to be 9. 10 is not equal to 9, therefore my test failed. You can also test negative cases, which is quite important. So if I go, there was a, let's see, say require new number not equal to 0, right? And now, if we did set number, and we called it with 0, right? Fails, and it tells us that it fails, so the error number cannot be 0. If we're wondering why, we use our verbosity. And we can see, oh, what's happening? We call set number with 0, and it reverts with this error, number cannot be 0. Oh, yes, we have this error in our contract, and that's the issue that's happening. A very good testing strategy is always to test that your contract fails properly. So you need to test this require statement. So in order to do that, you then say test set number fails correctly. And then you would say pm.expect revert with the revert message. And then when you call it, it should revert, and this test should pass. And once again, for shorthand, forge T is forge test, --empty is --match test. And we have a failure because in our setup, we are setting a number to 0. Let's set it to 1. And there we go. Our test passes because our contract is failing correctly. It's pretty important to test both negative and positive test cases in your contract so that you know your contract is failing correctly. Right. We can also run, you saw there, that was a matching the test. But if we have multiple test contracts, so for instance, if we had another test contract over here that was, let's say, counter2.t.sol, right? And in this test contract, we just had one test. That was just this. You could then call this and say, I just want to run this contract. You could say forge test -- match contract and the contract name, counter test 2. And it will run all tests in that contract. Whereas if I did forge test now, it will run all tests in both of the counter and counter2 contracts. See, counter there, counter.t.sol, and somewhere it runs counter2.t.sol there, counter test 2. Okay. Next we come to deployment. So once you've written tests, once you've got your contracts up and running and you've tested them thoroughly, you want to try and aim for getting about 80% test coverage to 100% test coverage. The way you check, you literally just do forge coverage, AGE coverage, and it will analyze it. And well, if you have a contract number cannot be 0. Oh, yes, because this fuzz is setting it to 0. So yeah, you can see this fuzz test X is being set to 0. Therefore, this is failing. And that's what this is telling me. It's telling me the argument is 0 on this run of the score of this test. And that's why it's failing. So you could do something like call the bound function, and you would say bound X is equal to bound one to the biggest number that will fit into a UN256. So this will exclude 0. It will go from 1 to the biggest number known that can fit there. And now all these tests should pass. Oops. Right tests. Oh, we're still failing. But yeah, let's not monkey about with that too much right now. That's just this fuzz test that is once again calling it with 0. So in our deployment scripts, once we've tested and we've got all our tests passing and we're happy, now we want to deploy to testnet. We could deploy to our local Anvil instance as well. We're now going to write a script also in Solidity. So here we can see, if I kill this, clear our terminal. We've got a counter.s.sol file, and this is just our deployment script that will deploy this counter contract. We inherit the script contract from the standard Forge library, and then we import our contract. We create an instance of it. We don't need a setup function. But what's important is we do need this run function. Every deployment script should inherit this run function. It's what Solidity looks for. And it's what will it's the function that will deploy your contract. You could have other functions here at the bottom, but the run function is the most important one to have. This start broadcast function is what tells Foundry that you are now going to broadcast transactions to the network. If you don't have the start broadcast, it won't deploy to a network. And here we just call the counter. We just instantiate a new counter contract. So if I go here, actually, no, let me not go here. Let me just see if I can deploy this to our local Anvil instance. So to start an Anvil instance, we spoke about Anvil in the beginning. We just type ANVIL. And it spins up a local chain directly on your computer. It's pretty awesome. You can see it comes preloaded with 10 addresses, each loaded with 1,000 Ether, 10,000 Ether. and it exposes the private keys for each of those addresses. So you can import them into your MetaMask wallet and use them for testing. There's your chain ID, and it shows you all the information that you need. This would be your RPC URL. So if I remember this correctly, we got a new terminal. Then let's go for script, and then call script. So forward script is exactly like saying forward test. That tells us we want to run tests. This now tells us we want to run a script. So forward script. And then we give it the path to the script we want to run. So it's script slash counter.s.solve. And we give it the contract name that we want to run, in this case, counter script. Because you can have many contracts in one file, you need to define which contract you want to run. And then you would do, you would enter your private key. But in this case, we're going to use costs built-in wallet function. I'll show you guys that later. And it just goes dash account and your account name. I can't remember what mine was. I think it's guest wallet. And then dash RPC dash URL, and this would be the what is it? And then dash broadcast. Right, broadcast tells you that you want to actually deploy this contract to the network. If I don't put this broadcast flag in, it will just simulate the contract. I enter, and it gives me some error. I think I put in the wrong RPC URL. I have to dig around to go and find it. But if I can show you the contract that we did last week. Over here, you can see we've got an RPC URL for Sepolia. And we've got in our env file, we've got our Sepolia RPC URL here that connects to Alchemy. We've got a private key for our Anvil instance, and we've got our ETH-Scan API key. So this just connects to our Foundry.toml file, and we can deploy contracts using that. So if I want to deploy this to Sepolia, I would then just check my wallet. So if I go cost wallet list, it shows me a list of the wallets that I have already set up on my machine. But if we wanted to create a new wallet and not share our private key in our env file, which is very, very bad practice, you never want to do this with the private key that owns money, that handles money. This is a publicly known private key, so it's fine. It's from the Anvil instance that I spun up. So it's totally fine to copy this here, but never ever do this with your own private key. You always want to do what I'm about to show you. And that is using cost. So you can create a new wallet. Let me see if I have this here. There. So if I do cost wallet import dash interactive, if I copy this, kill this. If I do this, it will ask me for an account name, and I can just give it, I will say, course wallet. It will ask me to enter a private key. I can then look at my terminal and say Anvil. Oh, it's already running. Oops, my bad. Let me just kill it in this instance. And run it up in this instance. So you can only have one Anvil instance running at a time. Right. And if we use, say, this private key number 3, it's asking us to import our private key. I've pasted it in there. It's hidden. It doesn't show you. It doesn't expose the private key at all. Hit enter. It asks for a password. Also doesn't show you the password. But if I hit enter, it then stores that private key and creates a wallet in a encrypted key store on your machine. So now you never ever have to expose your private key. It shows you the address for the wallet that you have. And if you check it on Anvil, 0x3c44, 0x3c44. So we know those match. So now you can do something like what is my local testnet? We could probably check it on the Foundry site. If we did Anvil, right, and yeah, it tells you every single thing you need to know about Anvil, except what the RPC URL is. Anyway, let's deploy this to Sepolia. So now we can go forward script slash, we've got a deploy script here, deploy demo. .s.sol just means .script.sol. And we give it the name of the contract, which is deploy demo script. We do -- account, and we give it the name of our account that we just created, which was a course wallet. The course wallet. And -- Sepolia. And if we run that, it should simulate what it would cost and if our deployment would be successful on chain. So there we go. And it's asking me something about, oh, right. Because I'm in the wrong folder. There we go. Oh, and it's moaning about the salt version. So we just do that. What is our salt version? Yeah. Put 20, let's make it 25. It should match. Everything should match. Versions. Okay, let's try again. And it's compiling. Ask me for my password. And so I know things are good. Just thinking about life. And there you can see. Your script ran successfully. It deployed to that chain ID, which is the Sepolia ID. That is the estimated gas that you'll pay to deploy. And this is the amount of ETH that you should hold in order to pay for that deployment. So that's pretty much how you use cost to deploy contracts. You don't ever expose your private key. You always do this interactive import. You can also use cost to read contracts on the network. So if I go back to this, here we go. You can use this command. That's verification, sorry. Here we go. Cost call. That is basically just to read. It's a read-only call, and it will just read any view functions or pure functions on a contract. Cost send is basically a transaction. You want to sign a transaction, and this changes state on the chain. So if I do this, so we know that we have a deployed instance of the demo contract already on chain. We can see here in the broadcast folder, it tells you all the transactions that we've done. We do run latest, and it tells you this is what you've deployed, that's your contract address, that's your transaction, that's the input data that you had. So we can copy this address and we can put it in here. And basically, we can check what function do we want to call. So we're calling this demo contract, and let's just call a view function that is get owner. So we want to call the get owner function. So instead of balance, we're going to call get owner. Takes no arguments. So it's just like the function signature. Don't need any arguments here. And because we set up an RPC URL, we can just call it by its name. It's Sepolia. And we hit enter. And it reads our contract. And there it gives us the owner. It pairs it with these bunch of zeros because an address is only 160 bytes. And this is a 256-bit word. So it needs to pad the zeros. But if we look here, 81EFCAE, and if we look on ETH-Scan, which we have over here, on our contract address, the contract owner is 81EFC. So we've successfully read the owner address from this deployed contract. So that's how you can interact with deployed contracts and test your contracts using the command line. You don't have to build your own front end. And then moving on, verification. So once you've deployed your contract, it will not automatically be verified on ETH-Scan. You can either run this command once you've deployed it, and then the Foundry will then compile the bytecode of your contract and submit it to ETH-Scan. And if the bytecode matches your contract and the on-chain bytecode match, then ETH-Scan will verify your contract and your contract will become visible on-chain. What I mean by that is you will be able to read the code of your contract like this and interact with the read and write functions. You could also verify in one command. So if I were to do something like this, dash dash broadcast dash dash verify, this would do a deployment and verify a contract in one step or in one call, provided that you have your ETH-Scan API key set up in your TOML file. It's very useful to verify your contracts. It does create a lot of trust with your users, because then your users can inspect your code and see that you are not trying to scam them or rug pull them or anything like that. So yeah, that's pretty important. And then in closing, this is a few of the best practices for Foundry. It's just you need to write tests for your contract before deployment. You need to aim for coverage above 80% and test all edge cases and failure cases. So like I showed you, you want to test for zero values. You want to test that if a contract is supposed to revert, it does so successfully. You should always have good key management practices. You should never ever store your private keys in plain text in your .env file, because if you accidentally push your .env file to your GitHub, or you show it to someone on screen, that person can copy your private key and steal all your money. You should always use this cast tool to import your wallet, and then store it in an encrypted key store. Then you could just refer to the wallet account by its named import, and that's much safer and much easier. You really you want to keep your scripts in the script folder and make your deployments idempotent. And this just means that if I run the deployment script on Monday, it spits out an address and deploys a contract. If Mokhtar comes in on Tuesday and runs the same deploy script, it has to do exactly the same thing. It can't deploy to a new address or set some other funky variables in it. The deployment scripts must do the same thing, no matter who calls it, and no matter how many times you call it. And then finally, you should log your deployment addresses. I did not do that in the deployment script, but most times a deployment script, you'll see something like this, and then you go address demo, and then you'd say demo address is the address of that, and you'd write it to a file somewhere in your project, and then this way you can keep track of your deployments, especially if you have upgradable contracts. And you do quite a few upgrades, you need to keep track of which was the latest version of your contract. Keynote. So yeah, deploy before your deployment, you've got to write comprehensive unit tests, fuzz tests, and what they call invariant tests. You've got to test all your edge cases. You've got to check for re-entrancy issues. We'll cover that next week. You've got to verify all your access control. So all your functions should only be callable by the people you need them to call. And you've got to audit all your event emissions. So ask yourself, am I emitting useful events? And will the events help my front end stay in sync with the blockchain? Do I emit events on all important state changes? And are my events indexed so that the front end can search them easily? And then for your deployment checklist, as I said, use Cast Wallet to import your private keys, verify your contract on chain, and test on testnet first before you go to mainnet. And then last but not least, log all your deployment addresses. And then just to recap, we went through what Foundry is. It's the modern Ethereum development toolkit for Solidity. Contracts are written in the source folder. You compile with Forge build. You test with Forge test. You can run all your tests. You can run a single test, or you can run one contract full of tests. It's up to you. You can deploy with Forge script. You can interact with your contracts using the Cast tool, and you should always verify your contracts on Etherscan. So yeah, for you guys next, if you can follow along, you guys are welcome to set up your own Foundry installation. and then just play around with the basic contract that comes with it. That would be this counter contract. Basically play around with it. See if you can write in 1 or 2 functions, write a test for it, see if the tests pass, write a script and see if you can deploy this to a chain, Anvil or Sepolia or any chain of your choosing. If not, that's okay. If you have any questions, feel free to ask. But yeah, that's it for this week.
Awesome. Thanks, Miles. Anyone got any questions?
I felt like I spoke a lot.
Yeah, no, it was good.
It was a lot. Yes, Tanda.
So I have a question for Vickers.
Yep. Okay.
How did you create that ATM thing from your laptop? It's cool. How did you do it?
I used a little something called Codex.
Codex.
Yeah.
Oh, so
Did you-
how does it work?
It's like Claude Code, but it's from ChatGPT.
So Codex is an app or just a tool?
It's a tool.
Oh, so did you install it via VS Code or in the command prompt?
No, it's its own.
Yep.
It's its own thing.
So both though, because you can use VS Code, you can use Claude Code or Codex in VS Code, but you do have to buy it. It's basically like ChatGPT Premium or something. Well, not Premium. I think
Yeah,
it's Pro
yeah.
version, and then it works.
So you have to buy it. How much?
It's like $20, $23 or $20 or something like that.
Oh, okay.
A
It's
month.
20.
Oh, yeah.
Yeah,
No.
it's $23. It's $23 for Codex when you get the Pro. That's per month, and then Claude has changed their things where it's now I think $100 a month. Then you get Claude Code.
That's expensive.
No, wait, really?
Yeah.
So they cancel the whole code on the normal version,
Yeah.
on the Pro
And-
version. Okay.
Things are, and the 15th of June, things are changing even more.
Really, what's happening then?
Yeah, they're gonna, because now you can use Claude Code on many things, doing agent work, doing code work, doing inline coding. Like you can call Claude Code via command line and send in a request and then get code out. So that's what they use with things like OpenClaw, you know, these
Yeah.
other Claw type of agents. Now they're going to split agentic work versus normal chat and Claude Code work. So you can code in Claude Code, that's fine. But then if you want to do heavy agent stuff, that you're going to have to use APIs instead of in Claude Code. So they're trying to split things that are heavy usage to push those to use the API instead of using Claude Code.
Rough. It's just discrimination with the credit card.
So anyone who's using Claude Code for agent type stuff, they're going to start having to pay way more for what they get.
Gonna start hiring juniors again to do the stuff. I saw something about companies. They started not hiring juniors and letting the AI do stuff. And now that AI tokens are too expensive, they're just like, oh no, let's get the junior in to write that stuff, and we can save on our tokens.
Yeah.
Gone
It's
full
true.
circle. But yeah, Tando, sorry, you don't have to use these paid apps. You can literally just go to ChatGPT or Claude or DeepSeek. And if you have a smart contract that you want to build a front end for, you can literally just give it the smart contract and say, I'd like to build the React front end Can you please help me hold my hand through it or explain to me how to do it? And it will do a fantastic job.
Okay, thank you, sir.
You can try Lovable. It's got some free tokens per day, I think. So it gives you some credits to play around with, and it can make a front end.
So
Yeah.
how long did it take you to create that ATM thing?
Oh, it's like 5 minutes.
5 minutes? Nah. Are you
No, it's
serious?
quick.
Yes,
Yeah, it's quick.
Yo, because I thought it took you hours, 3 hours max.
No.
So because Vickers has been coding for like 50 years, I see it sounds like it's easy for him to build something that quickly. But for us mere mortals who don't really understand, we've only been coding for a few years or a few months, it would take us a bit longer because we have to build an understanding of how things work. So for you and me, it might take 2 hours.
Well, so he's been coding for 50 years.
I'll just exaggerate.
Oh,
No, it's 24. 24.
oh, okay. Just
And when I
checking.
was 24 years ago, I think I was still in school.
Oh,
No, it's 24 years ago.
Jeez.
I was not even
finished,
born.
finished,
Yo.
finished studying, and I was working then. Yeah, I
Yo,
was working.
I was not
this
even
job.
born.
But yeah, so like for Vickers using these kind of things, he can iterate quickly through these kind of things because he's seen it all before. But for you and me, it would take us a bit longer. So maybe a day, and we can get something running. But
Oh,
it's still a lot shorter than what it would be without an AI.
yeah, because
Oh,
I'm
yeah.
still learning. I'm still learning Python, so it's a lot. Yo.
No, but even with AI, you can learn Python a lot faster if you actually give it the
Because I'm
code
using
and ask it questions.
because I'm using an app called Free Code Bootcamp, where it gives me test how to build stuff, like how to build a machine, how to build a chipper, yeah, etc. Those kind of things.
I would say check
You
out
can-
Code Academy. Like Code Academy is like cheap. I think it's like if you can prove you're a student, it's like $10 a month or something. Here's the URL. But sign up and they'll give you access to a lot of the free Python stuff. If I'm not mistaken, Python is free.
Because
In Code
the one that I
Academy.
use, it's also free. I don't pay because I just do those tasks and assessments. Then they test me. Then from there move on.
But fair enough. But like in my opinion, Code Academy is a bit better. And then they also have career pathways and stuff like that, and they teach you in a more systematic approach.
Oh,
You know what I mean? So I don't know. Like I don't think there's anything wrong with code. What's it? Code bootcamp or whatever.
Free Code Bootcamp. Do you know it?
Yeah, I know it. Like, but I don't think there's anything wrong with it per se. But like for me, I tried it out way back when, and I didn't like it, and I tried this, and I preferred it. So there's also another one called Cyber Library or something.
Don't let him put you down, Tando. If you making progress with Free Code Camp, keep on with it. As long as you're writing code, as long as you're practicing, that's the important thing.
Yes.
Yeah. No, fair enough. Like fair enough. I'm not knocking it. Just like my personal thingy. Like you know what I mean. You try different learning things, and like whatever works for you works for you.
Yes.
But then there's also this other one called Cybery. I think it is. It's like cybery.it, but I can't seem to see their catalog, and it's like not loading. But they used to have. I think this is the one. If I'm not mistaken, they might have free stuff. There's free access. But it's free cybersecurity and thingy courses. So check this one out as well. If you dig it. What did you put? Realpython.com. Is that any good, Vickers?
Yeah, that's
Cool.
quite a good one. It's got a lot of beginner stuff. It's got tutorials on different topics. There's like so much in there. It's crazy.
Oh,
Okay,
Mm.
awesome. Guys, do you want to call it a night? We've been going on like Terminators.
Yes.
Is Paolo and Simpiwe still there?
Yeah.
yes, they're still there.
No, they're coding JavaScript now.
Fair enough. Yeah, I hear. Okay, cool, guys. I'm gonna kill the recording now. Sorry, I didn't kill it earlier. But thanks a lot, Miles. Really appreciate you. Thanks everyone for joining.
Thank you, sir.
I appreciate you
Cool,
guys.
cool.
Cool. Enjoy your night.